Good morning, everyone. Good morning, everyone. Myself, Ram Prasad, Assistant Professor, Department of Civil Engineering, Ramco Institute of Technology. On behalf of Ramco Institute of Technology, I welcome all the participants for this technical webinar series 2, day 2 session. Also, I welcome the speaker of today's session, Dr.V.M.Sounthararajan, Professor, Department of Civil Engineering, CMR Technical Campus, Hyderabad. Now I invite Mr. Karthikeyan, Assistant Professor Senior Grade, to introduce the resource person.
Good morning to everyone. It's my pleasure to introduce about today's presenter, Dr. V.M.Sounthararajan Professor. He completed his B.Tech Civil Engineering at VIT University in the year 2008 and postgraduate in Structural Engineering in the year at VIT University, Vellore campus in the year 2010 and completed his doctorate in Structural Engineering at VIT University in the year 2014. His research interests are micro crack characterization of cement-based materials, fracture of ductile pseudo strain hardened composite material, cost-effective construction material production, structural properties of cost-effective construction materials. He has professional accomplishment, is well reinforced with teaching overall 9.5 years of experience, including 2 years of research at VIT University and 8 years of experiences in industries, and also published more than 56 research papers with reputed journal publications. With this brief introduction, now I cordially invite Dr. V.M.Sounthararajan to talk about high yearly strength of low and high modulus of fiber reinforced concrete. Kind attention for the participants. Attendance Google form link will be shared to your chat box. All the participants are requested to put your attendance. And feedback Google form link will be shared after the session through your email. Also, participants are requested to pin the presenter, Dr. V.M.Sounthararajan's presentation. Sir, Sounthararajan sir, you can proceed, sir.
Sir, 1 minute.
Yes. Participants are requested to pin the presenter, Dr. V.M.Sounthararajan presentation.
It's 2 minutes, sir. Something technical issues. 2 minutes.
Yes, sir, no issue. Kind attention for the participants. Attendance link will be shared at the end of the session. So all the participants are requested to put your attendance through the Google form, which will be shared at the end of the session in the chat box.
Yeah. So 5 minutes, sir. It will opening.
Yes. Attendance Google form will be open until the after the 30 minutes of the session. Feedback form will be shared directly to your mail after you have given your attendance.
Yes, sir. It's loading. Another couple of minutes. It's going
Yes,
to
sir. Yes,
press.
sir. Yes, sir.
Yeah. Shall I start, sir? Hello, Karthikeyan, sir.
Sir, you can start, sir.
Yeah.
You can make slideshow screen, sir.
Yes.
டைப் பண்ணிருங்க.
Yeah. சார் F5 ப்ரெஸ் பண்ணா வர மாட்டேங்குங்களா சார்?
வரலையே சார்.
இப்போ பாருங்க. ரீடிங் வியூ கொடுக்கலாம்ல?
சார் யூ கேன் பிரஸ் F5 சார்.
F5 தான் ப்ரெஸ் பண்ணேன். ஓகே. Okay. Sorry for the delay. Anyway, I will start, sir. I will start. After that, it will rectify this problem. Huh? Zoom. Is it visible, sir? Karthikeyan, sir?
Yes, sir. PPT is visible.
Uh, okay. So, good morning to one and all who are present there through Zoom Meet. Let me introduce myself. I am Dr.V.M.Sounthararajan, professor in CMR Technical Campus, Hyderabad. So I would like to thanks for giving this opportunity, Ramco Institute of Technology, Rajapalayam. Today I'm going to talk about high yearly strength of low and high modulus fiber reinforced concrete. So mostly a very important role for fibers using for high strength or high yearly strength of construction industries. So it's a major role for fibers. Fibers made up of steel fibers or polypropylene fibers or organic fibers or waste fibers. So depending upon the tensile strength, we can predict the low and high modulus of fiber reinforced concrete. So let's see the various stages involved to produce a high strength concrete. So any research scholar or MTech students or any researcher, they are going for conceptual mixed design or standard mixed design. Either maybe packing density or identification of the best mixed proportions based on the standard mixed proportions like M20 or M25 or M30. So next one is that material. What material we are going to use? That is also one of the major strength enhancement. So mostly nowadays we are practicing using only for OPC, ordinary Portland cement or Portland Pozzolana cement, PPC only we are using that. So ordinary Portland cement, you know that maximum calcium content is more around 40 to 60%. So in the case of Portland Pozzolana cement, if you are using that 30% fly ash based cement, we are using OPC 70%. That's why we are using for Portland Pozzolana cement. So because why I'm talking about OPC and PPC, because strength enhancement is very important. We are triggering the strength by altering the waste byproduct like a supplementary cementitious material to trigger the strength. Or suppose if you are using the supplementary cementitious material, everyone knows that it's a waste byproduct material collecting from the industry. Waste byproduct material collecting from the various sources of industry. For example, thermal power plant is there. We are collecting from fly ash. Ash is flying that objects is like ash. So that ash we can say it as two type is there again. Bottom ash, fly ash is there. Bottom ash is a more gravity is going to settle in the pulverizer tank. The bottom fly ash is there. We are collecting that at top positions. Again, fly ash is two type is there. Class F and class C fly ash is there. And these are one of the waste byproduct material and very nowadays is a good strength enhancement like a slag, GGPS, ground granulated blast furnace slag also are the most supplementary cementitious system. Silica, nano silica fume is there, and then rice ascas is there, marble powder is there, lot of waste, and now recent trend they are using for sugarcane bagasse, collecting from sugarcane industry. So raw they are collecting after burning some 800 to 600 to 1200 degrees Celsius, and then sieving through passing sieving the IS 90 microns or 45 microns. Again, sieving methodology is there. Wet sieving method and dry sieving method is there. Okay, this is a supplementary cementitious material. So metacolin that is also one of the material, waste byproduct material. So next ECC. So what is the meaning of ECC? Means engineering composites, engineering cementitious composites. Engineering cementitious composites means while using the any type of fibers. So fiber is a major role for to improve the bending stress. That is a major role, not in the case of compressive or other strength parameters. So most of the research work, maybe the paper work they identified while you are using the fibers, compressive strength enhancement is there. No, that is wrong. So we can see real strength enhancement in terms of bending stress in flexural strength only. Either you can use any type of fibers depending upon the dosage, depending upon the optimum limit. So for example, steel fiber. So depending upon the optimum, they can go for up to 2%. If you want to, what is that? If you want to slab polypropylene fiber, so you can use 0.1, 0.2, 0.35%. It's depending upon the what is that your grade of concrete, and then packing density is good, and you can choose for what is that this type of fibers. So next, so accelerators. I told high yearly strength. So high accelerator is there. This is an accelerator. So we can use for accelerator calcium nitrate or calcium chloride is there. Apart from that, steam curing also one of the major role for high yearly strength. The steam curing, the product we can use for concrete. So we can use for steam curing. So that is that type of product is we can use for precast structure. Okay. Next is a very important role for super plasticizer. So super plasticizer is a high range. Nowadays a high range water reducer is there. High range water reducer is there. So like rapid hardening admixtures is there. So 300 ml to 500 ml for 50 kg of cement. So per liter, maybe the cost is 100 rupees. Rapid hardening, super plasticizer is there. So super plasticizer, why we are using the super plasticizer? Super plasticizer is the high range water reducer. So everyone knows that as per IS, they are mentioning low water cement ratio, it will give the highest strength ratio, highest strength. So that is a reason mostly that you can see that ISO 1026 to 2019. So you can see the free water cement ratio. So you can choose depending upon your grade of concrete. You can choose the curve 1, curve 2, curve 3 is there. So depending upon your characteristics, predictions. So then you can predict the water cement ratio. After that you can design. And as per 1026 to 2009, if you are 19, if you are using the mixed design, so depending upon the slump is very important role. After 50 mm, after increasing 25 to 30, so 3 percentage is we are going to adding the to what is that to identify the calculate the water content. So next, so if you are using this material and grade of concrete, and now you are going to identification of best mix. You can identify the best mix based on your grade of concrete. So we can go for size reduction, cost effective. We are going to one of that size reduction is the cost reduction, cost reduction, size reduction in the flexural beam. So depth of the concrete we are going to reduce up to 5 to 25 mm. Same mix proportion. Parallelly, we are adding for fibers. Fibers is the major role for size reduction in beam concrete, up to 5 to 25 mm, depending upon the usage of the fibers. So these fibers, everything we are using that, and finally we are going to checking the what is that rapid. Sir, my slide is visible, Karthikeyan sir.
Yes, sir, it's visible, sir.
Yeah. So I
couldn't. But participants are requested to make slideshow, sir.
Slideshow. Okay, I press F5.
I request the participants pin the presenter, Dr.V.M.Sounthararajan. If the slide is not visible, I request the participants pin the presentation, Dr.V.M.Sounthararajan. Sir, solung sir. Yes, sir.
Sir, I pressed F5 is not working, sir.
Sir, in the option you can see, sir, view slideshow.
Now, okay.
Same, sir. Okay, sir, you can make it zoom. Now it's better,
yeah,
sir.
Yeah.
Okay.
Better because okay. F5 is not working.
Okay, sir, it's visible, sir. You can proceed, sir.
Yeah. So we are using supplementary cementitious system, engineering cementitious composites. So everything, and we are going to size reduction of the concrete volume reduction because of the cost saving. Then we can check it that whether the concrete is really worth or not, depending upon the durability test. Everything is okay, strength is good. If you are checking the durability or test any durability properties, is going to fail while using the this type of what is that introducing the cementitious supplementary cementitious material. So that is the reason water absorption also is a major role for checking the durability. Or rapid chloride is the easiest test. This one, that's why what is that I put it in rapid chloride pump RCPT test. Okay, this one. So next material. Let's see the materials usage. I told supplementary cementitious is waste byproduct material already. I told. So we can use for by content. So used for binding material by weight of binder content because OPC if you are most suitable for only for OPC. Ordinary Portland cement is the most suitable for supplementary cementitious material than compared to PPC. So next to engineering cementitious composite ECC mentioned that. So showed incredible there's flexural and tensile strength for various mixed proportions. Some of the journal paper they mentioned or optimum fiber 1.5 percentage if you are using that compressive strength enhancement up to 50%. That is wrong. You can see that truly measurement in flexural or tensile strength, split tensile strength only. So low modulus fibers, let's see that low modulus fibers is nothing but if you are using that nylon fibers or polypropylene fibers or acrylic fibers if you are using, so we can measure because of the tensile strength is low modulus fiber. So used for a reinforced in ECC. Flexural strength, I told flexural split tensile strength pull out test resistance also is very important if you are using the what are that fibers, steel fiber or polypropylene. So mostly then addition energy and toughness between the fibers and the composite matrix. So low modulus fibers cause lower flexural strength and bonding to matrix than that of other fibers. However, it is suitable for good cost quality. I told quality wise what that is good. We can use that balance especially for construction purpose. Suppose if you are using drainage is there, we are going to use for slab. So instead of RCC, we are going for fibers like what is that polypropylene fiber is most suitable for drainage slab. So we can use and then we can cast the fibers. I can use the what is that slab in the drainage because drainage is sulfated mostly the corrosion. Most of that corrosion is going to occur. So due to avoid that polypropylene is a major role. If you are using steel fiber in the drainage purpose, you can the anti-corrosion agent we can use in the fiber before using the steel fiber. I'm talking about plain cement concrete along with the steel fiber or polypropylene fiber. You can make a slab. So some of the what are the fibers types I added in that I collected from the net only high modulus fibers. So high modulus fiber steel fiber. So this one is a both in hooked fibers depending upon the L by D ratio, aspect ratio, length by diameter. We can say it as aspect ratio, and then that aspect ratio we can go for calculation of volume fraction. That volume fraction in terms of percentage 1%, 0.1%, depending upon the fiber usage of the fiber, which I told earlier. Okay, so that length of the fiber average or standard deviation they mentioned the length of the fiber, and tensile strength is a very important role. So most of the tensile strength and the L by D ratio is a more important role for enhancement. Okay, these are the cold drawn steel wire, high yield strength, crimped type of steel fiber is there. So glued steel fiber also is there. Glued means is what is that each steel fiber glue also is there. That glue if you are adding with what is the cement fresh concrete, the glue is going to spread it like a adhesive. It's going to act a adhesive. So that glued steel fiber also available. Like glued means it's going to act, what is that react as a super plasticizer. And then this type of what is that corrugated steel fiber also is going to major role for strength enhancement in terms of flexural rigidity. So I told what are that normally reinforced with steel concrete is relatively brittle. Everyone knows concrete is a quasi brittle material. Quasi brittle material. So steel is a ductile material. If you want to improve the tensile strength, because mostly MTech students and research scholar they are using plain cement concrete while using for flexural strength, like a third pointing or center point loading is going to broken into two pieces. It won't give for any cautions. So what is a caution? It won't give any caution. Suddenly is failure occurred because of the quasi brittle material plain cement concrete. That case we can go for what is that to avoid to improve the brittleness, to improve the tensile strength. So while using for what is that a steel fiber, any type of fibers. For many applications, it has become increasingly popular to reinforce the concrete with small, randomly distributed fibers. So we are talking about fibers, how we are going to use the fiber while using the pan mixture or what is that, any type of mixture if you are using laboratory, I'm talking about laboratory. If you are using the pan mixture or any type of mixer, horizontal type mixer, first to for cement to fine aggregate, coarse aggregate, dry. We are up to 2 to 3 minutes thoroughly mixed. After that, we are adding the water along with the chemical admixtures like a super Plasticizer or accelerators. After that, we are randomly. After that,
இது குறைச்சிங்க அது 12 மணிக்கு தான் இது ஃபீட்பேக் கொடுப்போம் 12
hello,
மணிக்கு தான் குறைச்சிங்க ஃபுல்லாக
hello,
குறைச்சிங்க ஒன்றும் அவசரம் அவ்வளோ
hello. So if you are using the steel fiber,
நான் 12 மணிக்கு தான்
if
எல்லாமே 12 மணிக்கு தான் முடியும் மூணுமே
if
2 மணிக்கு நான் ஒரு
Karthikeyan,
மணி
some disturbance is there.
2 மணிக்கு
Hello, Karthikeyan sir. Hello, hello,
sir.
Karthikeyan sir.
அட்டன்ஸ் கொடுப்போம் 11 மணிக்கு அட்டன்ஸ் கொடுத்து அட்டன்ஸை போட்டால் முடிஞ்சது அப்புறமா பார்த்து
Hello,
Yes, sir.
sir. Some disturbance is there.
I request the participants mute your audios. I request all the participants mute your audios.
Hello.
I request the participants mute your audio.
அதான் சொல்கிறேன் ஸ்லைடு ஸ்டாண்ட் பிபிடி எங்கேயும் வரமாட்டேங்குதுன்னு பார்த்தா அப்படிதான் ப்ரோக்ராம் அப்படி தாங்க
Hello.
அட்டன்ஸ் கொடுத்துட்டு வெளில வந்துடுங்க
Hello.
Yes, sir. Sir, your voice is hearing.
Somebody is disturbing.
Yes, sir. I'm looking there.
Hello. Something Jansi Rani.
Yes, sir. I will take it, sir.
Yeah. Hello.
Sir, wait for him. Sir, now you can check, sir. Now I think it's okay.
Yeah. So randomly distributed. See. Yeah.
Can you make slideshow, sir? In the option nearby animation, there is slides.
One minute, sir. 1 minute. Animation. Yes.
Nearby animation, there is slideshow.
So animation. I clicked. It's not.
Sir, it's working, sir?
No, sir. No. 1 minute.
Sir, okay, sir. You can proceed, sir.
Just a minute. Yeah. No, sir. Still, this problem is not okay. Okay, randomly distributed. Suppose if you are fiber, if any type of fibers, if you are randomly distributed while using the fan mixer or any type of horizontal type of mixer, that randomly distributed. So that randomly distributed after keeping the fresh concrete like compressive strength or split tensile strength or anything. If you are using the what is that? Hello, a concrete. The says distributed fibers, we are using fresh concrete. After that, see the next slide is very important slide, continuous versus described reinforced fibers. If you are suppose if you are using any beam or slab, so what are the, we can provide the steel reinforcement at the bottom reinforced, so we can improve the tension reinforcement, cover zone and compressive zone. So cover zone maybe is a weak, this cover zone in the bottom of the tensile reinforcement, so cover zone is weak. So while you are using the steel fiber, the cover concrete will be improved, or cover concrete will be improved. Shrinkage stresses more in the case of reinforced concrete. Whereas in the case of fiber reinforced concrete, we are adding. So this is a very important what is that measurement. We are adding randomly distributed. This is a flexural, for example, flexural, randomly distributed. After table vibrator, after internal vibrator, the fiber, the orientation of the fiber along the beam axis, the orientation of the fiber along the beam axis. So that means homogeneous steel reinforcement is going to improve. High reinforcement index is there. Residual shrinkage stresses is very less. See that stress distribution at high volume fractions. So while you are loading that, we are adding randomly distributed. After alignment, the steel fiber along the beam axis, the orientation of fiber is along the beam axis. So that means if you are adding the load, so what are the steel, each steel fiber is going to absorb the tensile stress. So that means automatically the crack zone also, the first crack also, it will take more time. It will take more cracking time. So the next, let's see the benefits of fiber addition: homogeneous concrete, segregation resistance, and flexural tensile strength, compressive, high spalling resistance, impact resistant, high toughness, and fatigue endurance, long-term serviceability. So next, I'm talking about natural fibers like organic fibers or waste steel fibers. Natural fibers like mostly nowadays we are using sisal fibers. Coir type fiber is a coir type also fiber we are using for naturally sisal fibers. So that is also most of the research work, they identify the good strength enhancement like in terms of flexural rigidity. And waste steel fiber, these are the waste steel fiber. So lathe waste or grill work, we are collecting from the grill work, we are collecting the waste. This type of waste fibers also we are incorporating the what is that plain cement concrete like a based steel fiber reinforced concrete. So to cause the to enhance the what is to reduce the cost effectives. Next, we are high yearly. The topic is I told high yearly strength. So what is the calcium chloride? If you are using any type of calcium chloride or what is that for polypropylene fiber, if you are using, we can go for calcium chloride because calcium chloride is chloride. If you are using, is going to corrosion. Is going to occur the corrosion due to avoid the calcium chloride accelerated. So one of the chemical admixtures, calcium chloride is available. We can use that one. Or if you want to use the steel fiber along with the calcium chloride, you can anti-corrosion agent, you can use it. If you are using anti-corrosion agent, then the corrosion is going to minimize. And most of the journals, they mention that if you are using the any type of fibers, is going to what is that pumping to affect the slump retention. While using the pumping also, slump retention is going to affect. So parallelly, other super plasticizers also you can improve that if you are adding the super plasticizer by weight of binder content. Slump, what is the high slump also in the range of 7 to 9 inches is going to that. Some cases maybe is a low water cement ratio along with the high range water reducer. It's going to true slump is going to getting. instead of collapse or shear slump. Suppose if you want to calcium nitrate also is a more in mortar and concrete is used as a multifunctional additive as a set accelerator plasticizer long-term strength enhance and antifreeze admixtures. Used binding material and the amount of calcium nitrate affect the characteristics of the concrete mixture and the strength of hardened concrete. So okay, we are using for accelerated, and then accelerated. What is that? Everyone knows that accelerating admixtures. If you are using that, we need not wait for what is that long term. Suppose post construction payment is a road payment is a RCC payment. What is that? Cement payment is here. So that any damaged and the road payment is damaged, like runway airport. If you are using the damaged, this type of calcium chloride accelerated or calcium nitrate is going to very useful. Within 4 to 5 hours we can open the traffic, close the traffic. After modifying within 4 to 5 hours, within 4 to 5 hours we can open the traffic. So now apart from that accelerated, steam curing also is a major role for high early strength. The special type of curing fabrication is required. So steam curing also what is the mostly is effective. So what is the meaning of
Hello.
steam? What is the meaning of steam curing? So meaning of the steam curing
Hello.
is a steam curing cycle consists of initial delay prior to the steaming, a period of increasing temperature, a period of holding the maximum temperature constant, okay, a period of decreasing the temperature. So steam curing is a very important. Suppose if you are adding accelerated along with the steam curing, steam curing, if you are casting the concrete either compressive strength or flexural or split casting, you casted, and then today is a today casting, next day demolding. After that you can keep it to what is that steam curing. So per day 6 hours minimum curing is required. So 3 days you can keep it to what is that 6 hours curing. Then your strength enhancement is going to improve. Accelerator also if you are using, and steam curing also if you are using. So why I am telling this accelerator and steam curing, if you are using fly ash content is what is that more than 25%, then if you want to good strength enhancement as per the code, they as per the code or many research paper they identified only for 30% of fly ash usage. If you want to what is that more than 25 to 30%, 50% if you are using along with the accelerated, along with the steam curing, 3 days, each day 6 hours of curing period. So 3 days, definitely the strength enhancement 3 days and 7 days is more than, no need to wait for 28 days of the compressive strength. Suppose if you are using that American Society of Testing Material Type 3 cement, it's a low alkali Portland cement. It's a special purpose of hydraulic cement that produce a high yearly strength relative to the normal type of type 1, type 2 Portland cement. This is the ASTMC classifications. If you want any what is that type 3 cement, so definitely what is that if you are high yearly strength. In the box component, what is that C3S is that component is mostly the ultimate yearly strength C3S. So if you are altering the C3S content, definitely you will get the high yearly strength also. The foreign countries, what they are using, that altering the chemical compositions. But see that our country, Portland Pozzolana cement, 10 years back only they identified. But in the case of a researcher, so 1957 they identified the Portland fly ash is a pozzolana material, is a good bonding strength. 1957 the foreign country they identified, and they used for horse is there, no horse blood they are used for a supervisor. Horse air is they used for a fibers, and they invented 1957. So see that India is a developing country. We are 10 years back only they introduced Portland pozzolana cement. Next, very important cost reductions, size reduction in concrete. So this is a snapshot or image for flexural along with the Japanese yoke setup. Japanese yoke setup is there. In that, after that we can use for bending equations. We are applying for bending equation, then third point loading PL by BD square. Okay, so while using the bending equation, you can solve it, and then you will get the formula PL by BD square. So is that your Japanese yoke arrangement setup is there, and the corresponding the load, corresponding incremental load 5 kilonewton or 10 kilonewton. What is the dial gauge reading? Dial gauge reading in terms of division. Then you can measure size reduction. Then after that, you one of the toughness. So toughness is a graph 3 software is available. So toughness, we can measure the toughness because of while using the steel fiber. So toughness is nothing but the ratio of average load carrying capacity offered after cracking due to the presence of steel fiber reinforced divided by steel fiber or any type. So divided by the flexural strength of uncracked concrete specimen provide the RE3 index, are also called toughness index. This toughness index is what is that? Let's see that next slide. This is a graph software. This graph software, you see the graph. So while using the any type of fiber, reaching the ultimate stress divided by what is the vertical axis is stress, horizontal axis is a strain. Stress by strain is a Young's modulus of elasticity. If are using the stress, see the stress is maximum reached while in the case of steel fiber, any type of fiber. After that, stain hardening is there. See the stain hardening because of the fiber. Fiber is a major role for the stain hardening. In the case of plain cement concrete, if you are using the flexural, so if you are applying the load, is going to broken into two pieces in the plain cement concrete. Whereas in the case of RCC or reinforced steel fiber reinforced concrete, see the ultimate maximum load is reached ultimate after the stain is hardening. The stain hardening. That stain hardening is very important role for the fiber. If you want, you can download in the graph 3 software in the online, and then you can use the Japanese yoke arrangement. Each every 5 kilonewton corresponding dial gauge reading, you note it down. After that, you can upload it in the software. It's going to come is going to analyze the toughness index while with the help of the graph 3 software. So mostly, what is the reason of, I told, what is the reason of fibers, bridging the fibers. So how we are going to bridging the fibers, let's see in the snapshot. Suppose, so bridging the steel fiber, I used initially this type of snapshot used for both end hooked steel fiber. After, see that after applying the load, the steel fiber is going to state position. Is going to the state position, and see the alignment of this is one of the failure taken the snapshot of the failure of the flexural beam. The flexural size of the beam is 100 mm, 100 mm, and 500 mm. Other type sizes also available, no problem. You can use any type of size of the beam. See that initially the fiber is both end hooked. After applying the load, the stain is going to withstand the load. The steel fiber is going to state position. It means the pull-out resistance is more than parallelly the corresponding stain hardening also is going to improve. That's why I mentioned the effective fiber bridging by the steel fiber shown in figure occurred when after the failure had resulted in the concrete beam and showed a significant enhancement on the post-kick characteristics. So in the toughness, post-peak, pre-post-peak resistance is there, characteristics is there. You can see that. Next. This is also one of the microscopic view for steel fiber. So if you are any type of concrete, sliced the concrete, we are going to use for sliced concrete with the help of microscopic. See the dot, that the circular dot is there. No, it's a steel fiber. So we are using randomly after slicing the longitudinal axis, concrete sliced, and that sliced you can view with the help of microscopic petrographic. If you are using that, then you can see this steel fiber is a circular shape. It's block dotted is there. No? That is a steel fiber along the longitudinal axis. I slice the concrete along the longitudinal axis. That means orientation, any type of vibration, an internal vibrator, table vibrator, the fiber is automatically alignment along the beam axis. It's indicating. Then only it's going to affect the load. Then only it's going to improve the bending stress. So next, very important, one of the my results or samples I posted in that slides, test results for size reduction. Size reduction is very important for in the case of the flexural. So flexural beam is a size, what is that flexural beam? Depth, 100 mm depth, length is 500 mm. We cannot touch any, what is the 500 mm is a constant. Depth only, depth of the concrete only we are going to reduce. 5 mm we are going to reduce, 10 mm we are going to reduce, and 15 mm we are going to reduce. And then see that fibers, if you are adding for first one is the 0.5 fibers usage of the 0.5, and then 1.1% of the steel fiber. So everything is a negative. That means there is no improvement in the flexural. While adding the more, what is the percentage? Optimum is 1.5% by volume fraction steel fiber. The improvement is there in the, what is that, above the positive axis. Improvement is there. So size reduction also is very important role for the cost saving the concrete. Suppose 100 mm, 100 mm, 500 mm, if you are using rebar or steel fiber, so if you are using that same flexural strength. So that's why 15% or what is the, depending upon the usage, I told in the earlier, depending upon the usage of the fibers. So 5 to 25 mm, we can reduce the depth of the concrete. If you are reducing depth of the concrete simultaneously or parallelly, same results which you used for which we are going to use for 100 mm depth of the concrete. So that is also very important measure. Most of that, what are that, they are telling that already is a flexural strength depth of the concrete is very less. Then how we are going to reduce that? That role is going to, what is that, take care of the steel, any type of steel fiber, mostly the steel fibers is going to take care. Okay, thank you. Any queries, please?
Sir, thank you for your given nice presentation, sir.
Yeah,
Sir,
thank you.
there are some few questions, sir.
Yeah.
Hooked or crippled fiber, which one is better, sir?
Pardon?
Hooked or crumpled fiber, which one is better, sir?
So mostly hooked is a better strength enhancement than compared to the crimped fiber or correlated steel fiber. Because why I am telling that both end hooked fiber is going to affect you, no? And the law in the end only is going to, after cracking, the end is going to try. So that hook end is going to try extend the stain hardening. So most probably the hook end correlate, some results, research studies, they are identified that correlated, but mostly in the practically or any major project they did only for both in hooked steel fibers.
Okay, sir. So next, in slide 8, is it possible to orient the fibers as shown in slide 8? Practically, is it possible as shown in slide 8? Sir? Kindly give some orientation patterns.
1 minute, 1 minute. Yeah, slide 8.
Is it possible to orient the fibers as shown?
Yeah, this is a, you can, if you want, you can really, you can use in the what is that lab. You can. That's why I last slide I mentioned that along the this is the longitudinal axis. This is the longitudinal axis. I slide somewhere portion. I slide and I see the petrographic. This, if you are cut the longitudinal axis and the steel fiber is a circular because of the orientation, randomly distributed, but it's required for vibration. Its required vibration automatically is going to settle the what is along the beam axis, longitudinal axis.
Yes. Sir, what is the software using?
Graph 3 software. Graph 3 software is available, but if you are using the Graph 3 software, if you are using that, definitely yoke, Japanese yoke arrangement, you have to keep it. That yoke arrangement is very easy. We have to fabricate it. We have to fabricate it, and along with what is that, we can keep the dial gauge reading. So dial gauge reading corresponding, note it down the what is that load, 5 kilonewton. What is the dial gauge? 10 kilonewton, what is the dial gauge reading? Graph 3 software is available to measure the post-peak or pre-peak toughness, RE3 index. So if you want, I published many papers in that area also. What is that? I will keep it in the, I will send it to you also, or type it in the Google. Type it in the main name, my name, Google. It's coming, size reduction of concrete journal papers. Okay, next, sir.
Is there any alternative to steel fiber which can be incorporated in concrete? Alternative to steel fiber which can be incorporated in concrete.
Alternate, I don't want to, per kg 300 rupees for any type of fiber, approximately I'm telling steel fiber. I don't, research purpose, I don't want cost effective fibers. Then I can go for what is that waste fiber we are collecting from lathe. The grill work is there. That scrap item also we can use for steel fiber. Or if you want to use for white glass, what is that bottle, plastic bottle is there, chopped into number of pieces. That also you can use for the what is that fibers. Alternate steel fiber as alternate is the same material property. If you want, alternate is a lathe or grill work. What is the waste fiber you can use. Polypropylene. If you want to, nowadays they introduce for organic fibers. Sisal fiber. Many research workers they are concentrating sugarcane bagasse with sisal fiber. They are going to excellent report. But type of what is that? But definitely accelerated curing. Accelerated curing nothing but accelerated dosage or steam curing. Accelerated curing is required. Different types of accelerated curing. Hot air oven curing is there, steam curing, and many types is there. That is the best method is a steam curing. That also you can use. Steam. What is the meaning of steam curing? Pressure cooker is there. So if you are preparing the idli, so what is that? Is a pressure. The steam is ingress into the what is that material. Then automatically boiled. Same thing also. We are in, because if you are using the pozzolana is a later. Pozzolana is a what is the later strength gain. That's why PPC. If you are seeing the graph for OPC, PPC. OPC is at 28 days. We will get for maximum compressive strength at 98%. When then compared to PPC. So PPC is a lateral age gain strength. After 56 days or 90 days, you will get for the more strength. So that's why definitely what is that alternate is the steam. What you asked alternate is a waste lathe steel fiber scrap item we are using for the fibers. Next.
Sir, which type of fiber produces more tensile strength in concrete? Steel fiber or glass fiber or carbon fiber? Which one is economical?
Economically steel fiber, obviously. Yes. Carbon fiber is less percentage we are using. Carbon is maybe we are using for 0.2%. Steel fiber only is a more tensile strength or flexural. Polypropylene is a low modulus. We cannot use that one. Carbon fibers is a low modulus. We cannot use. Which one is a high tensile strength? That is a steel fiber. Tensile strength is more steel than compared to other type of fibers. Or either organic or inorganic. Next, sir.
So same. Which that best fiber that can be used in concrete, both structural and economic?
Structural and economic is, so what is that? Both end hooked is a economic. As per my knowledge, I am telling. Yes. As per my knowledge, as per research, many research work our students are did. So what is the both end hooked fiber is a more results than compared to what is that correlated. So yes. Fiber is and one more very important is there. I told whether the people are noticed or not in the slide 7. In the slide 7. What I was slide 7, for example, reinforced concrete. Many you can see the many example. 20 years or 25 years aged building is there. If suppose the top floor, so there is no proper drainage for rainwater. There is no weathering course. So after 20 years, the ceiling inside the room, the roof slab is what the cover concrete is going to fall down. So what is the need? So what is the why the cover concrete is fall down? The chloride content, water content is penetrate into the steel bar. The steel bar is going to what is the bulging the rod. Initially 12 mm. After penetrating the chloride content, 12 mm is going to bulge for 14 mm. That's why concrete, because we are providing steel reinforcement bottom zone. After that concrete cover concrete is there. that automatically bulging the rod is going to fall down. The concrete cover is very important to roll for cover concrete is a steel fiber.
Yes, sir. The next one, what is the best way to coat PBA fibers with oil agent? PBA fibers with oil agent. What is the best
I
way
can't.
to coat PBA fiber with oil agent?
PBA fiber, I didn't understand what is the meaning of.
Okay, sir. Sir,
I will refer it. PBA means what is that? Something polyvinyl chloride or something? I don't know. What is the pronunciation? You can. What is that abbreviation? You can tell me. Then I will explain.
okay, sir. The
Next
next one,
is
how to improve the sustainability of engineered cementitious composite?
how to
Improve the
sustainability.
yes,
Improve. Yeah. Improve the
sustainability of engineered cementitious composites.
composites. How to improve means that special type of what are that steam curing.
Yes.
And then if you are using, if suppose for example, suppose if you are using the fly ash, mostly we are collecting fly ash, class F fly ash. Yeah, it's a suitable because class F fly ash. For example, I am telling class F fly ash is a low calcium. Already we are going to alternate. We are going to alternate OPC, ordinary Portland cement. We are going to alter. Already calcium content is more. That's why we are using OPC. And along with the fly ash, class F fly ash instead of class C. Okay. Then if you are using that one, I code or research some journal paper, they restricted up to optimum 30%. So in my knowledge, we can go for wet sieving, dry sieving. So dry sieving is at 30% for usage of the that cementitious material like fly ash. You can go for what is that wet sieving. Take 90 we are using only for 90 microns in the practically, but the average particle size of the cement, each average particle size of the cement grains is 45 microns. Is it not possible to sieve the 45 microns instead of 90 microns? Is a very rare, it will take more time for 90 microns. So cementitious improvement is what is that we can go for special type of curing method, and along with the accelerated fabricated is required. Steam fabricated is very, very important. For precast structure only we are going to use. Or any type, for example, nano silica fume up to 12.5% only we are using that. If you are carefully altering the packing density, that's why don't need to go for the mixed design. You can see the packing density. I invented one of that packing density, fine to co-segregate ratio. Packing density concept I did in PhD. So that also you can take it. No need to go for standard proportion. One is, for example, M20, 1:1.5:3. That standard mix proportion I don't want. I am going to alter my proportion based on the material characteristics. I'm going to alter the proportion. I'm going to alter based on the slump value also. Okay, so these are the apart from the careful selection of your mix ingredient, that is very important, and usage of the waste byproduct is also very important, and the special type of curing method you have to introduce. Special type of curing method you have to introduce, and you can go for what are the special type of chemical admixtures. So these are the very important role, but careful mix design is very important. Anything. And apart from that, quality of the material is very, very important. State to state, the quality of the aggregate, concrete aggregate is, suppose some area is what is that, blue stone is there, some area is a rock stone, what is that rock is going to vary. So we cannot go for all the state, we cannot predict all the states are same, what are that aggregates, material characteristics also very important.
Yes, sir. So next, how the aspect ratio affect the strength of concrete?
Depending upon the aspect ratio, length, we cannot go for some extents only, we can length by diameter. We can, what is that, we cannot go for 60 mm divided by length is 60 divided by 0.5, or 30 mm divided by 0.5, 60 mm. So what is that? It's a higher aspect ratio, it won't give for, or the already guideline is there. You can refer the code. So fiber reinforced concrete guideline is there based on the L/D ratio aspect. So you can follow the accordingly you can follow, then only you will get it, or you can go for trial and error method. Based on the trial and error, what is the guideline also doesn't matter. But trial and error method is, if we are researcher, trial and error method also you can invent a new what is that aspect ratio. Some journal, some code book, they mention that a higher aspect ratio it won't give for strength. But if you are trial and error method, because you are choosing the careful mixed design instead of standard mixed design, everything trial and error basis only. We cannot predict this is a particularly this type of fiber is only for good strength enhancement. We cannot predict anywhere. OPC, if you are using fiber L by D ratio, aspect ratio, more aspect ratio, if you are using only OPC, you will get good strength enhancement. If you are using supplementary cementitious material, then same aspect ratio, it won't give for good strength enhancement in terms of bending stress, flexural rigidity. I'm talking about flexural rigidity. So I'm asking what is the reason of what is that split tensile strength we are calculating. I'm asking anyone answer. Why we are calculating split tensile strength? What is the need? Compressive is enough, and then tensile is a flexural is bending stress is enough. Anybody say, you can answer me, no problem. Why we are calculating split tensile strength? What is the need? I'm asking you people. Okay, next question, sir.
Sir, does the fiber orientation is possible in mixing of different fibers?
No problem. Possibility is, that's why alignment along the beam axis.
Yes.
If vibration is table vibrator or needle vibrator, anything is required. Compulsory is required. Without vibration, alignment is going to along the beam axis. Is going to saturate along the beam axis. Definitely, it won't work without any vibrator. Any type of vibrator, any type of fibers. Definitely, orientation of fibers is along the beam axis.
Okay, sir. So, is it any practice to reduce the balling effect of FRC without control the L by D ratio?
Yeah, I didn't understand. What is that?
Is it any practice to reduce the balling effect of FRC without control the L by D ratio?
No, I think so. It's not possible. In my knowledge. FRB, again FRB, what type of FRB you are using that? Okay, for example, FRB using, for example, I'm telling no need to fiber. You can go for column only for lime surki mortar. You can use only lime surki mortar along with the FRB. So same what is that same bending stress? You can what is the flexural strength you can observe? I'm talking about, see this, listen carefully. Beam, you take beam. The beam is made up of only for surki mortar. You can mix with the surki mortar along with the warping with the FRB. Then you can check it. Definitely, what is that strength enhancement is there. So L by D ratio, without controlling L by D ratio, okay, you can go for FRB. FRB is a good effective. For example, repair this FRB is coming to what is that repair and rehabilitation. It's very suitable for FRB. Yes, sir.
Yes, sir.
Anything, sir. I asked one question. So anybody has answered, please. What is the need of calculating the split tensile strength of concrete? Hello, sir.
Yes, sir.
Okay, sir. Anything? Any queries?
Sir. Same. Again, they're repeating the question, sir. Which is the best material to be used as fiber as per structure and economic consideration?
Pardon, sir?
Already you have answered, sir. The question is
multi-story building now see foreign countries now hello.
Yes, sir.
Yeah, foreign countries they are using mostly the fibers to improve the tensile strength cover concrete along with the anti-corrosion agent. Okay, sir. Anything else?
No, sir. Sir, thank you for giving the excellent presentation about fiber reinforced concrete, sir.
Yeah, only my side is I am asking apologies only that full screen is not working. I don't know. Yesterday we practiced it. That time is worked. Now I don't know what that is only from my side.
So someone answered for your questions. Concrete have
Yeah.
some percentage of tensile strength, so we calculate the split tensile strength.
What is that? What is the answer? Some percentage of tensile strength. No.
Some percentage
no.
of tensile strength, so we calculate.
No, that is wrong. See, concrete is there. Concrete is the tensile strength is there. Ductile material only we can measure the tensile strength. Concrete is a quasi brittle material. Why we are calculating split tensile strength? What is the need? That is wrong.
For find out the E value of concrete.
No. To find out the E value, what is modulus of velocity? E value is the E value that is different. Using the if you are using compressor meter, the beam concrete along the what is that compression zone. I'm talking about tensile strength. That is different. This is different. So concrete, if you are casting cylinder is a 150 mm diameter, 300 mm height, and along with the center portion, if you are keeping with the compressor meter, and then secant modulus 40% failure load of 40%, each 5 kilonewton. What is the dial gauge compressor meter dial gauge reading, and then stress by strain. That is different. That is difference for modulus. This is what is that split tensile strength. I'm asking. This is different.
Hello, sir.
Yes, madam.
Sir, can you hear me?
Yeah, somebody's answer is 1/10 of the compressive strength. Hello. Yes, madam. Yes.
Sir, yes, sir. That's what I'm also coming to say, sir. It's 1/10 of.
Yeah, that is the diameter. Diametrically, in the top 1/10, the portion it will take for compression. Remaining it will take for indirect tensile strength.
Yes, sir. Yes, sir.
That's why diametrically splitted into two parts. Diametrically splitted into two parts.
Yes, sir. Yes, sir. That is
So
what
that's
sir.
why
We
it's
use yeah.
Tell me, madam. We use
proceed, sir. No, we use cylinder for which the vertical diameter, not sir. Then
yes,
this will
vertical.
be the indirect.
That vertical diameter means it's a what is that longitudinal axis or lateral direction. So, okay, if you are using that, it top 1/10. So it will take for compression. It will take for tensile, indirect tensile measurement. That's why some of the journal paper they are mentioning indirect tensile strength of the concrete.
Yes, sir.
That
Yes,
is equal.
that's
Split is the diameter.
yes, sir.
Yes. Anything else? Any queries?
Sir, everything is almost you covered, sir. All the questions. Sir, hello, sir. Hello, sir.
Hello, sir. Tell me, sir.
Sir, all the questions you have answered, sir.
Okay. One question only that you asked, I didn't answer that one. PPE something they mentioned. Okay. So I'll check it and tell you, sir. Okay. Anything else? Okay, sir. Shall I close it?
Yes, sir. We can make it closer. Thank you for your given good presentation, sir.
Okay.
About fiber reinforced concrete.
I'm not satisfied with this. Frankly, I'm telling you, that just 3 hours only I practiced yesterday night only. So because of I told I left in Hyderabad. I kept in laptop. Everything is there. So neck of the moment only 3 hours. This presentation I prepared. Okay. Anyway, no problem. So if you want,
you have covered almost everything.
If you want to type it in the Google, my name. So it's coming in the paper, and many papers are published that it gives some answer.
Yes, sir.
Okay.
Yes.
Okay, sir. Okay. Thank you.
Thank you, sir. Thank you very much.
Thank you. Okay. Okay, sir. Thank you.
Thank you for the insightful session, sir. Thank you, sir.
Yeah, thank you, ma. Thank you, sir.
One of the clarity session I have ever attended, sir. It was very good, sir. Thank you.
Thank you for all
Okay.
the participants, and thank you,
Yeah.
sir.
Yeah,
We
thank
will
you, ma.
meet
Thank
again
you.
for the tomorrow same time by the resource person Dr. S. Nagan on the topic Introduction to Finite Element Analysis. Thank you all.
Thank
Thank you, sir.